Welcome back to our lesson practice review, where we are in this video going through chapter 1, lesson 11 practice. To start off, we will summarize what happened in lesson 11, which is really a combination of a lot of our previous lessons. Since we're kind of nearing the end of the chapter, it takes a lot of the lessons that we have learned throughout this chapter, and now we're putting it together into one big question that covers a lot of different topics. So in this situation, we're dealing with all of our different transformations that we've learned all in one. So one type of question might be if you're given, an original function, let's call it f of x, and you're shown the other graph, g of x, we have to kind of list the equation that would make f of x land on top of g of x. Another way we might have to do things is if you're given the equation here, g of x is equal to, and then all these transformations, we may then have to kind of sketch out the graph of that. And so a couple different ways that we can see these, but we're now using all of these translations, reflections, and scales all in one problem. So for number 1, it says the function d of x is a transformation of c of x. Describe a sequence of transformations that could move c of x onto d of x. Now, there's a very specific order I'm going to do these in, and again, as we kind of get more practice with these, it will make more sense. But I'm actually going to be doing the left and right movement first in this case here. When I look at this equation, c of x, I see that my turning point here, this is kind of the key point that I want to be focused on, is at an x value of positive 5. So the first thing I'm going to do is I'm actually going to shift it 1, 2, 3 units to the left. So translate 3 units left, so that I now have this function that looks like this. And then now I'm going to be doing my reflection. It's like kind of an order of operations thing, where once I now do the reflection here and I get this function that looks like this. So reflect over the y-axis. And then lastly, I'm going to shift that 2 units down. And when I do that, now I have this function that lands right on top of d of x. So lastly, translate my function 2 units down. And there's a couple different ways that you could kind of list out how this works. This is just, I'm going to try and stay consistent over how we do these, and you'll see how the order of operations works as we go. So for number 2, we're going to change one number in the equation so that the graph goes through the given points. Now, this one's a little bit tricky because we kind of have to go through this in the correct order, or else it kind of messes things up. So the first thing I'm going to do is I'm going to graph what g of x would be in green here if we didn't change anything. So the first thing that we're doing is that we are shifting 2 units to the right from this part right here. And that would give us, I'm going to take 3 specific points to kind of mirror what we're ending up trying to hit. So we have this point right here, we have this point right here, and this point right here. So if we shift that over 2 units, then we get here, and then 1, 2 is here, and 1, 2 is here. So that's after just shifting it 2 units to the right. The next thing we're going to do is we're going to multiply it by 1/2. So when I do that, I'm going to erase these points in just a second, but all of the y values become half as big. So we got this one right here. And these y values of 0, if we were to divide those by 2, would stay the same. And now we get, a little bit more of a squat, or I guess wider graph. And then the last thing we have to do is this negative here. So the negative is going to reflect it over the x-axis, which instead of the vertex being at the y value of -2, we're going to flip it to become +2, which gives us this graph right here. And so what it looks like is these points are pretty close to the right spot. We just have it shifted over a little bit too much. So what we may want to change here is instead of shifting 2 units to the right, we may need to shift 1, 2, 3, 4 extra units to the right. So what I'm going to do here in orange is I'm going to leave it negative 1/2 because it looks like I do need the reflection. I do need to compress it vertically, but I'm going to change this shift to moving it 6 units instead of just 2. And that way it would end up landing in top of these 3 points to give me my new equation. All right, for problems 3 through 6, write an equation in terms of h of x that goes through the points. So to start us off here for number 3, we have h of x here where I'm going to take these points specifically at the same x values here and see what's happening. So looks to me that 1, 2, 3, 4, that's just 4 units lower. 1, 2, 3, 4 units lower, 1, 2, 3, 4 units lower. Yeah, so really this one here is the same exact function, except 4 units lower. So the way that we're going to write that is we're going to shift this h of x 4 units down. And so that means that we're taking the outputs and we are subtracting them by 4. For b of x here, we're looking for h of x and how are we going to land it right on top of those. When I look at these specific points, I see right here, and then one right here, and one right here. And so they're all keeping the same y values, but the x values are changing. So in this one here, I'm going to go ahead and shift it. And also I'm probably going to what looks like reflect it, because in this case here, whoops, the red one here is increasing. You can kind of see it's making this shape like this. Whereas if I were to fill in these 3 dots here, it would give me something looking the opposite direction. So I am going to be reflecting this one. And the way I'll do that is reflect it. I'm going to reflect it vertically on this one here. So again, over the x-axis here, if I were to reflect it, again, then it would take this part right here and look like this part right here, which is the shape that we are looking for. So that means that it's going to be multiplied by a negative in the front. When I do that, all my y values, we'll see what it looks like here in orange. My y values now become negative. So instead of -2, this becomes +2. Instead of +2, this one becomes -2. And I get something that looks like this. So that's after I put the negative in there. I now also looks like need to shift this 2 units to the left so that these 3 points in circled in red here then match up. So I'm going to shift those so that all the points are 2 units to the left. And the way that I would do that is h of x plus 2, which then gives me my correct graph here, lands in these spots, and gives me the correct function. Getting a little bit messy there because I'm trying to show each of the transformations one at a time, but hoping that kind of gives you the right formatting and help you understand how I got there. For number 5, c of x, what we're doing here is looks like it is extremely stretched out here. And when I do these, the nice part here is that my starting point that I'm dealing with is at 0, 0. And so I'm probably not going to be shifting it in any way because that point is not moving anywhere. And so really I need to worry about some stretches, compressions, some of that scaling, or any reflections. So in this case, again, if I were to look at just, let's say these points right here, it is not only is it going to be a reflection, but it is also going to be stretched out. And so I will go ahead and let's say I will do a horizontal reflection this time just to, make sure that we get an example of both. Horizontal reflection means that we are going to be doing a negative to the inputs or negative on the inside, which then after we do that, we now get these points, reflected over here. And so then we get, again, something that looks like that. And then I could keep going, but I'm really focused on these 3 points here. So that's the negative in the front of the X there. That does a reflection over the y-axis. And then from there, I need to stretch it out. And so my y value right now is at 2 and -2. And I see that we're actually stretching it to get to 8 and -8, which means that I'm stretching it by a factor of 4. So if I put a 4 in the front there, that would stretch this out 2, 4, 6, 8. And then same with this one here. And I would get this very extremely stretched out version that looks like this. And again, would continue on, but I know that it at least matches with those 3 points. Last of this group here for number 6, d of x. Got to do quite a few things here. It looks like not only am I going to be reflecting it over the x-axis, but also the y-axis. The reason for that is because I see that I'm starting like this. If I were to reflect it over the x-axis, that would give me something that looks like this. And then if I were to reflect it over the y-axis, then that would finally give me something that looks like this, which is what we're really looking for. If you can kind of see these 3 points is my goal. So I'm going to be reflecting both. The other part of this here is that it looks like I'm going to be shifting it a certain number of units up or down. And so when I do the reflections here, again, I'll do them in the same colors here. Hopefully our original function was blue. In green here, we got, looks like this. And then in orange, when we reflect it, it's going to be 1, 2. And I made that mistake there. And so now what I need to do, my last thing to handle here is I need to shift it down 1, 2, 3, and 4 units. 1, 2, 3, and 4 units. So to get that, my work here is going to be, it's going to be reflected vertically. It's going to be reflected horizontally and then shifted down 4 units to make it match up. And there's my final function that hits all 3 of those points. All right, for number 7, we got sketch a graph of a function f of x so that for some number k, g of x is equal to negative f of negative x, and h of x equals f of x minus k. Have the same graph. So this was a little bit of a theoretical question, a little bit tricky to kind of go through, but what it's really saying is that g of x, if we were to reflect it vertically and horizontally over the x-axis and the y-axis, we could get the same thing that if we just shifted it a certain number of units to the right or left. And that's usually going to be kind of like our function family, like our sine function families, because if we're dealing with something, let's say, that looks like this, when we're kind of dealing with this, if we were to flip it over the x-axis to start, oops, and then flip it over the y-axis, we see that it lands right on top of itself. And so that means that it is, going to match. It's technically an odd function. And then if we are shifting it k units to the left, if I were to continue this function, it would go on forever like this. If I just shifted it far enough to the right here, it would end up landing on top of itself, right? So like this function right here in green is going to match up exactly with this function here in green. And so if we shift it far enough to the right, then those 2 things would be equal. And so it's a little bit tricky, but it's an odd function that also would mean that if we shift it far enough, it ends up repeating over and over again. All right, for our spiral review here, we have a scatter plot, which is a bunch of different points on a graph, and we're asked to start off by sketching the line of best fit. So I can see that my other questions asked to write an equation and determine an estimate. So I'm going to try and make this line a nice, pretty line to help me. I'm going to start it, right here at my y value of 1. And I'm going to try and put some points in the middle of my data right here. And so if I were to connect these points, and that goes on forever, there's my line of best fit. For number 9, it asked me to write an equation of this line. And again, I specifically drew this line to be kind of nice for the equation. Again, I have a y-intercept of 1, and then a slope here. It's going up by 2 units and to the right by 3. So rise over run. We can kind of say that it's y equals 2/3 x plus 1, because my slope is here and my y-intercept is right there. Lastly, determine a reasonable estimate for the value of y when x is 21. Again, I'm just going to plug in 21 into my x value to give myself an estimate. 21. 21 times 2 is 42. Divided by 3 is, what is that, 10, 14? And 14 plus 1 is 15. So I don't know, anywhere around 15 was just my estimate. But if you gave me something around 10 to 20-ish, that would probably be a pretty good estimate. Again, this is just the equation that I came up with. Maybe not steep enough, but it looks okay, I would say, to give me a good estimate for this. But that wraps up our lesson 11 review. And we got one more lesson, which is lesson 12, which is kind of more of a statistical unit that you'll handle to go through before we wrap up chapter 1.